Hi, I welcome you all for the lecture series for UML diagrams from OOAD. Myself Shankar, Assistant Professor, Department of Computer Science and Engineering. Let us see the UML diagrams. The UML diagrams have many diagrams. The diagrams have been listed here. Use case diagram, class diagram, package diagram, interaction diagram. Interaction diagram furtherly divided into two various diagrams, that is sequence diagram, collaboration diagram, and next activity diagrams, state transition diagrams. The last one is deployment diagrams. Let us see one by one what was the use of all the diagrams. The first one is class diagram. The class diagram models the static structure of the system, and it shows the relationship between classes, objects, attributes, and operations. The purpose of class diagram is to analyze and design of software static view of an application. And it describes the responsibilities of the system and it's based for component and deployment diagram. Class diagram is the base for component and deployment diagrams. And this is the class notation to draw the class diagram. The class notation for the class diagram is rectangular, and the rectangular is divided into three parts. The first part will be a class name or name of the class. The second part will be the attribute of the class or properties of the class. The third one is behavior of the class or methods or operations of the classes. For example, here they have taken example for student. The class name is student and the student have some set of attributes. Here, name, roll number and section. And it has the operations called display student, add student, edit student and delete students. Additionally, it has some operators like plus, hash and hyphen. Plus indicates public property of the class. It means that it can be accessed anywhere in the class. And next, protected. Protected attributes is indicated with hash preceded with the attribute. And the protected attributes are accessible only for inside the class and the using in inheritance the parent-child class, parent-child class relationship. So inside the parent class and inside the subclass, it cannot able to access anywhere in the class. It means outside the class, we cannot able to access if once the attributes is declared as protected. But it is not for public. Public means we can access the attributes outside the class also. And next one is hyphen. Hyphen indicates private. Private attributes can access only inside the class. It means that even though if you have used a parent-child class relationship in inheritance, the child class also cannot able to access the private property because private in the sense it can access only inside the particular class. Similarly, third one is operations, right? So totally the class notation have three parts: name of the class, attributes or properties, behavior or operation or methods of the class. So three parts. Next one is object notation. Object notation does not have any special structure. It's similarly same as class. Only the changes the class name should be underlined. It means that it is object, right? It is object, rest all the same. So this is the object notation. If you want to represent any attributes without method, you can use the class look like this. For example, if you have a class called student, you doesn't have any method. You can have only properties like name, register number, and address. You can use two parts of the rectangular box. Next, visibility. Visibility we have discussed just now. What is public, what is private, what is protected. And the last one is package. Package can be identified with the tilde symbol. Next, association. Association comes under class diagram only. Association is actually a relationship between or relationship among classes. For example, if we have two classes called register and sale, the relationship is records the current, right? The register records the current sale. That is the association among the register and sale class. The next one is multiplicity. The multiplicity represents how many objects are connected. For example, the many diagrams are given here, right? One sec. For example, the first diagram, T, if you just consider T as an object, it has preceded with asterisk in the link, right? Asterisk in the sense 0 or more. It means that it may have connected with the object, it may not have connected with the object. Zero object or at least one or more than one, anything else. If it proceeded with one dot dot asterisk in the sense, at least it should have one object, and other than that, any number of objects. Suppose it should like 1 dot dot 40 in the sense, it has to 1 to 40. It should not exceed 40. It may be have one object or 20 object or 15 object or 29 object or 32 object or 40 object, but it should not be at least 41 also. It should have exactly 1 to 40. But I don't want such a way. For example, 1 to 2, 2 to 3, like I want exactly this much. That is the next one. See, there they have specified only 5. 5 in the sense exactly 5. If you want exactly 20, you just replace 5 as 20. And next one is 3, 5, 8. It means that you may have exactly 3 objects, or you may have exactly 5 objects, or you may have exactly 8 objects. Other than these 3 numbers, you should not have any number of objects. That is actually connectivity. And next, the diagram, class diagram. So here we have 5 classes: database, applicant, police, regional administrator, and passport administrator. A database is connected with all other 4 classes. Applicant class can have its own attributes and methods. Passport administrator can have its own attributes and methods. Regional administrator can have its own attributes and methods. Similarly, police also can have its own attributes and methods. So such a way you have to draw the class diagram. Next one is use case diagram. The use case model describes the proposed functionality of the new system. During this requirement gathering, the primary requirements of the systems are understood. These basic requirements of the systems are called the functional requirements. The use case are the text stories that are designed in order to understand the functionality of the systems. Also, we have some components to draw the use case diagram. The first one is system model. The system model must enclosed with the rectangular box. The entire system model must be enclosed with the rectangular box, and we have to provide that system name. The next, actors. Actors will represent such a way, this symbol. There also have 2 different actors, implicit and explicit actors. And next, use cases. Use cases must be identified with the oval shape, and inside we have to give the textual information what that use case represents. Finally, we have stimulus. That stimulus represents with the arrow marks. So an example use case diagram is given. So initially we have 4 actors called as applicant, police, passport administrator, and regional administrator. So that arrow marks are stimulus, that is connection with the use cases. Use cases are identified with the oval shape. The entire blue color rectangular, it's not exact blue, somewhat highlighted, right? That rectangular box is actually your system boundary. So we have use cases called login, submit details, check status, get details, verify, store verification, and issue passport. These are the use cases we have under passport verification system. We can give the use case name or system name as passport verification system. The applicant initially log in the website. Right after logged in, the applicant submit his or her details. After that, the passport administrator checks their login, whether it is valid or invalid login. Right after that, it goes to the regional administrator. Then from the login, the regional administrator get details from the given login, and he is verified. After verified, he store the verification. Based on this, police is getting the details from the stored verification, and police also verified. Right later, if everything is okay, then regional administrator issues the passport. Meanwhile, the applicant only check their status whether the passport is verified or not, whether what's the status of applied passport system. So such a way. So such a way you have to identify the system first. After identify the system, you should analyze what are the actors are involved in the particular scenario and what are the use cases we require. After that, you have to draw the actors and use cases. If you draw the use cases and actors, you should know the stimuli. Stimuli in the sense links, how they are interact with the actors are interact with the use cases. That is very important. And the next one is interaction diagram. Already I told you that there are two types of interaction diagrams are there. One is sequence diagram and another one is collaboration diagram. A sequence diagram is simply depicts the interaction between objects in a sequential order. In the name itself, we can able to understand because the name is sequence diagram. It means that the interaction between objects in a sequential order. And the next one is collaboration diagram. The collaboration diagram shows the object and relationship involved in that interaction. The objects and relationship involved in the interaction is collaboration diagram. So the first one is sequence diagram. The student is interact with the database. Initially, he has to enter the user ID, then password. Then the database verifies that whether the entered user ID and password is valid or not. That status is returned to the student. So here they have given another example. In this, they have customer is an actor and system and bank is there for class. The customer initially log in with his user ID and password to the system. The system is authenticated, whether it is valid or invalid. For that, checks for the availability. Suppose if not available, then the system is informed to the user it is not available. Suppose if it is available, then the system tells that to select the number and types of these seats. It is actually ticket reservation system. Right. Next, the customer book the tickets by paying either through credit card or debit card. Then if he is paying the money, then the bank should get verified whether the amount is valid or not. Maybe insufficient balance is also there, right? That's why the bank gets verified the system and returned to the system. Then the system is give the confirmation mail to the customer, and next customer may cancel the ticket. Then that request goes to the system, right? Then the system notifies the banks about the ticket cancellation because the amount must be recredited to the bank, right? That's why. And next, the amount, if it is cancelled, then the amount must be returned to the customers. So this is the sequence diagram for online ticket reservation system. So what the actor is involved, what are the processes involved, and what interactions sequentially happen. That's we need to draw with the sequence diagram. The next one is collaboration diagram. In collaboration diagram, what are the objects and interaction is involved in order that we need to say here. Initially, system, this is library management system. So here library system is there and borrower involved and librarian involved. So initially the system gets to submit ID card. We are verifying the ID card. So the system verifies the username and password. Next, the borrower searches the book whether it is there or not through the system. After that, if it is there, the librarian will issue the book. Sorry, first we need to initiate, next we need to initiate the request to book. Right? After the request to book is initiated by the borrower, the librarian issue the book. Next, the borrower may return the book. If he return the book, he has to check the validity, whether it is he has returned in valid time or beyond the return time. Suppose if it is beyond the return time, then the borrower should pay the fine. Next, the librarian must be update the data with the system. So this is the library management for collaboration diagram. The next one is activity diagram. Activity diagram is basically a flow chart to represent the flow from one activity to another activity. And activity diagram is used to describe the dynamic aspects of the system. So that example is given here for issuing passport, the same. So initially he has to log in, and next he has to submit the details, next getting the details, then they are verifying. If it is successful, they may issue the passport, otherwise the penalty may be as per the law. Next one is state machine diagram. The state machine diagram represents the events and state of the objects. The state chart diagram shows the life cycle of the object. So it has some components. First one is event. An event is significant occurrence of something. For example, customer insert an ATM card. Next, state. State is a condition of an object for a particular moment of a time. For example, waiting for user to enter the PIN. Next, transition. It is a relationship between two states is indicated using the transition. For example, when the system operator performs startup, the transition from idle state to active state occurs. The example is given for state machine diagrams. Let's say for ATM. Login, he has to give the details, has to get the details, verified and issues. Next, the another type of state machine diagrams. So here they are entering the member ID. If the member ID is found, then it displays the membership status. Otherwise, it shows membership is not found. The next one is a deployment diagram. Deployment diagram represents the physical architecture of the system. The deployment diagram shows various hardware components called nodes, for example, database server. Also, the deployment diagram shows various software components called artifacts that runs on each node, for example, web application, database, and so on. Also, it is the connection between various components called JDBC. So deployment diagram, for example, online courses. If it is online courses, where whoever log in to know the online courses, they should know the course details and they should log in and they may get the college details. The next one is component diagram. The component diagram is used to visualize organization and relationship among the component of the system. The example for component diagram of online course reservation system, the same diagram. And the next one is UML package diagram. The package diagram is used to represent the logical structure of the system. Using UML package diagram, the elements of the system can be grouped together. Package can be nested. That means one package may contain other packages. If the packages have some inner members, then its name must be shown on the tab. So the example for package diagram. So here user interface layer is there. So there they have a component called web. And next domain layer. In domain layer, they have packages called select college, select course, request seat, request for post. And they have another one, technical service layer. It has login and database. So each may be having interlink. Thank you. Thank you all for watching this lecture series. Thank you all once again.